Hi everyone. Today we're going to work on what is called the natural logarithm. So we're going to be evaluating and simplifying natural logarithm expressions as well as solving equations using and involving the natural logarithm. So let's talk about a natural logarithm is. So if you remember a while ago we talked about the natural base, which was, remember, base e. So we talked about e to the x is equal to some number, let's call that y. And remember that e is a naturally occurring number. It's like 2.71, blah, blah, blah. It's very much like pi, that it doesn't end and doesn't repeat. It's used a lot in population and bacteria growth and a lot of growth and decay kind of things. So we're going to be using what is called the natural log. So let's write, and remember that a logarithm and an exponent are inverses of each other. So let's write the logarithm of base e. So if we would do the inverse, we would go log base e of y is equal to x. Now the problem is we don't usually write log base e. So we go with what is called the natural log, and we use ln. ln is shorthand for natural log. And we just go ln, and then we would go y equals x. So natural log, ln, is a logarithm whose base is e. Okay, that's what we need to remember. It's a logarithm whose base is e. So all of our properties, so let's make a note of that before we get into the other stuff. So it's a logarithm whose base is e. Okay, so let's review our properties that we talked about last week. So we have the product property, and if you remember, that basically said that if we multiply two things, we can separate it by addition, or addition means multiplication. So let's use a and b. We don't want to get confused with x and y. All right, so we have ln of a times b, and that's going to be the ln of a plus the ln of b. Okay, so these properties still hold true. So the quotient property, so we have ln of a divided by b is the same as ln of a minus ln of b. And then our power property, which is where we had, let's say, ln of a to the b is equal to b ln of a, comes down in front. You can do the change of base formula if you want with ln, works just as well. But there's a little shorthand that we want to be aware of, and we'll talk about that in a little bit. Okay, so let's write the expression as a single logarithm. So here's the subtraction. And remember, subtraction means division. So I'm going to write this as ln of 16 over 8. Now, you can use the online calculator, the calculator that we've been working with. Here he is. And it does have an ln button. Here it is. It's over here on the left, to the left of 4. So ln, and we can do 16 divided by 8. 0.693. And we would get that. So 0.693. Okay? All right. In fact, you know what? Let me bring that up here so we can have easy access to that. All right, so let's try number 3 here. It says a ln of 4 minus ln of b. So remember, down up in front becomes an exponent. So this is ln of 4 to the a minus ln of b. Now remember, subtraction means division. So ln of 4 to the a all over b. And that's how we would leave it. All right, let's try another one. 2 ln 4 minus ln 8. Okay, so the 2 is going to come up here as an exponent. Okay, so ln of 16 over 8. Oh, we did that earlier, which is 0.693. Okay, all right, why don't you pause the video and try the even ones on the right-hand side. All right, guys, good job. Let's check this out. These are the answers that I got for the first 2. Okay. And then check out number 6 here. And that's as far as we can go because they both 4 and 6 both have variables in it, so we can't solve it. All right, so let's go ahead and try using the natural log and solving some exponential equations. So when we solve equations involving the natural log, okay, you take the ln of both sides just like we would do the log of both sides. And the reason we want to do that is because if e is involved, that's what we want to use. We want to use ln. And there's a reason for that. Okay, so just bear with me. If I said, okay, log base e of e, okay, is equal to something, that's the same thing as saying ln of e. Well, think about it. E to what power gives you e? Well, that's 1. And that's what happens when you use ln with an e problem. That you're always going to get the ln of e, which is automatically going to go 1. And even if I put it in my calculator, if I go ln of e, okay, which is above the division sign, so second e, oops. Let's try again. ln second e, we're going to get 1. All right, so that's always going to happen. So working with e and ln becomes a lot easier. Okay, so let's try one. So here we have 4e to the x is equal to 10. Now, just like the other ones, we cannot have anything with our base. So the first thing we're going to have to do is we're going to have to divide by 4 so that... Excuse me, I'm sorry. That e to the x is by itself. So we're going to divide both sides by 4 before we do anything. So we get e to the x is equal to 2.5. Okay, so now we're going to introduce ln to both sides. So ln of e to the x equals ln of 2.5. Now, bring the x down in front. All right, now, ln of e automatically goes to 1. So now we get x equals ln of 2.5. Okay, so I come over here, I go ln 2.5, close my parentheses, press enter, 0.916, and that's our answer. Okay, let's try another one. All right, so here, if you notice, we have things that are subtracted and multiplied with our base. Don't care about the exponent right now. We're only interested in our base. So that minus 2 is going to have to be added to the other side before we do anything. So 5e to the 2x is equal to 14. Now we're going to have to divide both sides by 5. So e to the 2x is equal to 2.8. Now take the ln of both sides. Bring the 2x down in front. Okay, so now the ln of e goes to 1. So now we have 2x is equal to ln of 2.8. So x is equal to ln of 2.8, whole thing divided by 2. Okay, so when you put that in your calculator, guys, just be aware that you have to close the parentheses around the 2.8 before you do anything else. Okay, so we're going to go ln 2.8. I'm going to close my parenthesis and divide that answer by 2. We should get 5.1. Let's make it 5. No, 0.51, sorry. 515. Okay. All right, let's try this guy. I don't know, this guy looks a little bit more involved here because our exponent is x minus 2. No big deal. We're going to do the same thing. We're going to take the ln of both sides. Okay. Bring the exponent down in front. Now I'm going to put that exponent in parentheses. I don't want to get myself confused here. All right, so the ln of e is still going to go to 1. Okay, so x is equal to ln of 28, and then we're going to add 2 to that answer. So I'm going to put that in parentheses so I don't forget. All right, so ln 28, close my parentheses, and then I'm going to go plus 2, and we get 5.33. All right, take a minute, pause the video, and try the even ones on the other side. Okay. The only thing I would say before you do that is that in number 4, it should be e to the 4x minus 3, not just e to the 4. All right, give those a few minutes, give it a shot, pause the video, see if we get the same answer. All right, guys, let's see if we got the same answer. So for 2, I got 2.71. Okay, now I made that e to the 4x minus 3, and I got 0.795. And in the last one, I got 0.597. And again, you can always check your work, but in these cases, we're not doing any quadratics or anything like that, so we're probably not going to get any extraneous roots. All right, so let's do our last group of problems here. We're solving logarithmic equations. In other words, we're going to have ln in the problem, not e this time. So in the previous problems, we had e, the exponent contained our variable. We're going to take the ln of both sides. Now here, e is not in the problem, ln is. So we're not going to take the ln of both sides. What we're going to use is we're going to use the definition. Okay, and we're going to use the properties. Okay. Now when I say using the definition, you just have to remember that e to the x is equal to y is the same thing as saying ln of y is equal to x. Okay, so if I start out with ln, okay, remember that's base e, so I'm going to go base e to the x, base e to the x is equal to y, and that's what we're going to use. All right, so let's try this guy. And again, we're going to want to start by making sure there's nothing with our, let's get rid of that 4. Because if I make it an exponent, and I got x to the 4th is equal to -2. And that doesn't make any sense. So I'm going to divide both sides by 4 first. And that's going to make our lives easier if there's a number in front. Instead of making it an exponent, we're going to want to get rid of it. So we're going to divide everybody by 4, and we're going to get the ln of x is equal to -0.5. All right, so now remember that's base e. So it means e to the -0.5 is equal to x. Okay. So I'm going to come over here. All right, and then I have my e to the x, so second e to the x, and I'm going to go -0.5. I'm going to press enter, and I'm going to get 0.60. Let's make it 7 is equal to x. And we're done. All right, let's try another one. Okay. All right, so here we have 2 ln of 3x minus 4 is equal to 7. Again, let's make our lives easier by dividing both sides by 2. We could make it an exponent, but then we would have to take 3x minus 4 and write it twice and FOIL and blah, blah, blah. Let's be honest, we really don't want to do that. So let's divide everybody by 2. So that gives us ln of 3x minus 4 is equal to 3.5. Okay, e to the 3.5 is equal to 3x minus 4. Okay, so we're going to add 4. Divide by 3. And again, I'm not doing anything until I have x by itself. Okay, so I'm going to put that in my calculator. Oops. Okay, there we go. Then plus 4. I'm going to press enter after that one. Divided by 3. And we get 12.37. And that's right. Okay, let's do this last one. All right, so again, we have ln of 3x plus ln of 2x is equal to 3. Addition means that we're going to multiply. So we have ln 3x times 2x is equal to 3. So this is ln of 6x squared is equal to 3. Now I'm going to be able to write it in e. So e to the third is equal to 6x squared. And again, I'm going to divide by 6. I'm going to find that answer, and then I'm going to square root that. So technically our answer is the square root of e to the third all over 6. Okay, so I'm going to go second e to the third. Okay, I'm going to press enter, divided by 6. I'm going to press enter, and then I'm going to square root that. Put the answer in. Okay, I got 1.83, and that's what I got before. All right, take a minute, pause the video, guys, and try the other 3, the evens, on your own. All right, let's check our answers here. I got 29.6 for the first one. And then the second one, I divided by -7 first before I did anything else, and then wrote it in our exponential form. So 0.282. And then our last one, again, I divided by 5 and then solved it. I got 7.36. So hopefully you got all those answers. Let's try one more. That's a little bit harder. Okay, so here we have our application problem. So we have a battery power available for running a satellite is given by the formula P equals 50 e to the negative t over 250, where P is the power in watts and T is time in days. So for how many days can the satellite run if it requires 15 watts of power? So basically the only information I know is I got 15 watts of power, and that's going to go in for P. So we got 15 is equal to 50 e to the negative t over 250. All right, so the first thing is I see that I'm going to try and solve for t, which means I'm looking for an exponent, which means I want to try and get my base by itself. So the first thing I'm going to do is divide both sides by 50. Okay, so 15 divided by 50, I'm going to get, let's get the approximate answer. Let's see if I get that. Approximate 3/10, 0.3. So 0.3 is equal to e to negative t over 250. All right, so again, my variable is in the exponent position, which means I'm going to want to take the ln of both sides. So ln of 0.3 equals ln e to negative t over 250. All right, I'm bringing that negative t to the 250 down in front. And ln of e is going to go to 1, so we're left with ln of 0.3 is equal to negative t over 250. Okay, so basically I'm going to multiply two sides by 250. Okay, let's see what we get when we do that. So 250 ln of 0.3. All right, negative 300.99. Equal to negative t, divide by -1, so 300.99 is equal to t. So how many days can the satellite run if it requires 15 watts of power? Approximately 301 days. I wouldn't want to go to 3.1. I would probably say about 300 days. So let's do that, 300 days. Because if we go to 301, it's probably not going to work. All right, let me know if you have any questions, guys. Have a great day, and I'll talk to you again real soon. Remember that we're staying safe by staying in. Talk to you again later.